All right, we will just pick up right where we left. Again, most of these questions are very simple. If you can visualize it, it's gonna be a two-step answer. So I don't know if we did this. It doesn't really matter. It's two steps. So she's loading stuff onto a truck and she has to drive up a ramp. So you know there's gonna be a triangle. This is the ramp, right? The truck is probably somewhere here, and you're trying to load stuff up into the truck. The truck bed is 1.5 meters high. So which part of this triangle is 1.5? Remember, the truck is here. So it would be the opposite side of this triangle. If the angle's there, the opposite side is going to be 1.5. The maximum angle of the slope is 35. Slope is always rise over run, yeah? It has to be this angle because the slope, if you do rise over run for this, it's going to work out. The opposite is right, the adjacent is run. So that angle is 35. Let's say this is A, B, C. The first question, how far is the rear of the truck from the point where the ramp touches the ground? So which side of this triangle are we looking for part A? It's not AB, so that's out. You have two options. It's
BC.
BC would be right. So sine, cosine, or tan to find BC. Only one of them is going to work.
Tan.
Tan is right. Tan 35 is equals to the opposite, which is 1.5, divided by the adjacent BC. Now we have a linear equation. How do we solve this for BC? Remember, it's in the unknown is in the denominator. Whenever the unknown's in the denominator, you want to
Multiply.
get rid of it. So this comes over here, divide both sides by 1035, and you are done. So the bottom is 2.14 meters. So we know this is 2.14. Part B, how long should the ramp be? How do we find this? We're looking for AC now. That's the only side that's left.
You can use cosine.
Yeah, you can use anything here. You can also use Pythagoras. So if you use cosine, it'll be cosine 35 is equals to 2.14 over AC. If you use sine, it'll be sine 35 equals 1.5 over AC. You can't use tan. That's the only one that you can't use. So you can use both sine or cosine, or you can also use SOHCAHTOA, not SOHCAHTOA, sorry, Pythagoras, and solve this for C. So all three of them will give you the exact same answer. So that one's pretty, whatever, it's pretty easy. Maybe we will just like brainstorm the next few questions. Okay, here. So there's a plane headed towards a ship. It's 1,200 meters high, and the angle of depression is 12. The question is, how much further does the airplane have to fly to end up directly above the ship? So relative to that angle of 12 degrees, which side of the triangle are we looking for? The plane needs to,
Adjacent.
the adjacent is right, and that's it, easy peasy. This one doesn't have a diagram. I think we did this one. Let's try maybe this one. So there are two towers. They are 375 meters apart. So the first tower is shorter, 14 meters. The second tower is 30 meters. And the distance between them is, what, 375. All right. A question. What is the angle of depression from the top of the second tower to the top of the first tower? So this is the top of the second tower. We're comparing this with the top of the first tower. It looks something like this. Which angle are we looking for when it says find the angle of depression from the top of the second to the first?
A.
That's right. We're trying to find this angle. Do we know EB?
It's 375.
What about AB? Do we know AB?
You subtract 14 from 30.
Right, so it's going to be 16. So we're trying to find angle A. There's a right angle right here. Sine, cosine, or tan? Only one of them will work.
Tan.
Tan. So it's going to be tan of A. And remember, now the angle's missing. Tan of A is equals to the opposite over the adjacent. How do we solve this for A? Do you multiply by 16, or what do you do to
You
find
do
A?
the inverse.
Yeah, you do the inverse. Whenever the angle's missing, you're going to do inverse. Make sure you're in degrees. So it's going to be tan inverse of 375 divided by 16. That is like 88 degrees. So that's the angle of depression, the answer to part A. Part B. The guards in the towers simultaneously spot a suspicious car parked between the towers. So there's a guard dude here. There's a guard dude here. And there's a car in the middle of the two towers. Let's say right there. Call that O. The angle of depression from the lower tower to the car is 7.7 degrees. So the lower tower is this. The angle of depression, remember, is always from the horizontal. So this angle, sorry, not that. This angle, always from the horizontal, is going to be 7.7. Let me just redraw this. There's too much clutter. So there's a short tower, tall tower. This distance 375. The car is somewhere here. And angle of depressions are always from the horizontal. Actually, the last question, I don't know if we did that right. Let me just double check. Because we found this angle, right?
Mm-hmm.
Is that the angle of depression?
It's not.
It's not. It should be minus 12. The answer to this should have been 12 degrees. So now this angle is 7.7. And then from the upper, it is 6.3. All right. And we know this was 14. That was 30. Which guard is closer to the car? Explain. Now what do we do? This pretty much means we don't know if the car is directly in the middle.
You have to find the hypotenuse of both of those triangles.
All right, let's find it. So again, using the Z rule, this angle will be equal to this. This angle will be equal to this. So the 7.7 is going to drop down here. That 6.3 is gonna drop down here. These are the angles. We know the opposite. We are looking for the hypotenuse. So, you know, the opposite hypotenuse, they're both gonna be sine problems, right? It's sine because we know the opposite. We're looking for the hypotenuse. Sine 7.7 equals 14 over AC. Sine 6.3 equals 30 over AC. Sorry, BC. Whenever the unknown is in the denominator, you're going to multiply both sides by the unknown. Like that on the left. On the right, it becomes 30 divided by sine 63. So let's find both of the hypotenuse. 14 divided by sine 7.7. That is 104.48. 30 divided by sine 63 is 33.67. All right, now we know the hypotenuse. Now what? We're trying to find which guard is closer to the car. Would finding the adjacent help?
Mm-hmm.
Maybe, could we have found the adjacent? Yeah, actually, we didn't even need to find the
I think
hypotenuse.
so.
Yeah, we could have directly found the adjacent. So I'll just use Pythagoras here. So 104.48 squared minus 14 squared. This one is 103. The other one will be, it's obviously going to be less. So this one's 15.28. So this guy is way closer than the other guy, and that's the answer to this question. I think we've done most of these. Maybe we'll do like a speed question. It keeps coming up. All right, so a plane takes off in a straight line and travels along this line for 10 seconds. So let's say this is the end of the runway. The plane has taken off. This is gonna be the path of the plane. And after 10 seconds, it reaches a height of 300 meters. If the plane is traveling at 60 meters per second, at what angle is the plane ascending? So we're looking for this angle down there, the angle of elevation for the plane. We know the opposite, but we're gonna need one more side of this triangle. How do we find the other side? Do we have enough information?
The adjacent is 600.
Yes. The angle is gonna be 30 degrees. And because this comes from the special triangle, looks like this. This is in the ratio, you can always sine inverse this, but this is in the ratio of 1/2. 30 degrees seems very steep, to be honest, for a plane takeoff. It's usually like, I'm gonna look this up. I think it's about 10 degrees. Maybe even that is too much. Yeah, 30 degrees is like, maybe it's like a fighter plane or something that needs to go somewhere. It's very steep. All right, let's move on from SOHCAHTOA's, which is pretty straightforward, right? Not that
Mm-hmm.
difficult. Gonna move into something called the sine law, which we have done. And the way sine law works is you're gonna need a set of either, oh, you need a set of, here, let me also pull in the diagram here so you don't have to draw it. So now sine laws is for when you can't use SOHCAHTOA. SOHCAHTOA is strictly for right-angled triangles. Sine law you'll use, and also later on cosine law you'll use for non-right angled triangles. To use sine law, you need a set. What do I mean by a set? You need either the opposite angle and its side. You see, this is a set. Capital B and small b are a set because the angle that's opposite to this, sorry, the side length that's opposite to B is this side length. Same thing as A and small a. You need an angle and the side that's opposite to that angle. And if you have one set, you can use the sine law. Cool?
Mm-hmm.
So let's see some problems. Care about that. Let's see this one. You need a side angle and the opposite side length. So here, this is what I mean. You see 80 and 12, this is a set because you have the angle and you have the side that's opposite to it. If we didn't know 12, then we probably couldn't have used sine law. It says find the length of AC. So we're looking for small b. Small b is the side length that's opposite to capital B. All right, so how does this work? We're just going to use the formula that's on the left side. We're looking for b. So I'm going to start here. B is unknown. Divided by sine of b. What's angle B?
55.
55. And that's going to be equals to the set that you do know. The side length on the numerator and the angle on the denominator. So the set that we do know is A and capital A. So it's going to be 12 is your A. And then in the denominator, you have the angle, the sine of the angle of 12, which is 80, like that. So B is simply going to be 12 over sine 80 times sine 55, right?
Mm-hmm.
That's it. And you plug that in a calculator, you'll get B. So that's the sine law used when you have a set for non-right angle triangles. This one, they haven't given us a diagram, but it shouldn't be that difficult. So in triangle DST, and the way this works is it's always in order. So DST, angle D is 47. Side length D is always going to be the side that's opposite to this angle. That's why it's called a sine law, because the opposite. 4778. Small s is 106, so small s is going to be this side length, opposite to angle S, 106. It says determine the measure of angle S. Do we have a set? Or do we need to do anything? Yeah, we do. 78 and 47. So look at this. You can either use this formula, A over sine A equals B over sine B. This you'd use if the side length is missing. Or alternatively, you can use an equivalent formula, which is this entire thing flipped upside down. It looks like this. Sine A over A is equals to sine B over B. This one you want to use if the angle's missing. It'll save you an extra step. This one always works, but you just have to like multiply both sides by the denominator because the angle's going to be missing sometimes, as is the case for this question. So I'm going to use this formula, which is the same thing. This thing, just 1 divided by this and this will give you that. So it's just flipped upside down. So now let's plug things in. On the left side, we're gonna do the things that we don't know. So sine A, we're looking for angle S. So it's gonna be sine of angle S divided by what? What's the side length opposite to angle S?
106.
106. So that goes on the left. On the right side, now you're gonna input the set that you do know. Sine of what on the right side?
47.
47. Divided by 78. So here to solve for S, step one, you're gonna multiply both sides by 106. So that 106 disappears. And then what do you do if you want to solve for S?
You do the inverse.
Yeah, you do the inverse. So it's gonna be sine 47, which is 0.73 times 106 divided by 78, and sine inverse of 84 degrees. Would it make sense for us to obtain an angle greater than 90?
No.
What about something like this?
Yes.
Yeah, it will, but I don't think we're gonna encounter something like this here. We'll look into this more detail another time. Yeah, again, these are pretty easy. Like we're gonna skip. Once you know, you know. Um, Maybe we'll do this one. The bridge question seems, or we'll start with. I like doing like these T questions. I don't know how it works there, but usually over here, I don't know if I've talked about this probably many times, but the questions in tests and quizzes and assignments, whatever, every single thing is based off of 4 different criteria. First one is called knowledge and understanding. Second is called thinking, which is this one. Third is called communication C. And then the last one is application A. So every single question will be based on one of these concepts. So this one, it says thinking. So let's see what we need to think about. I think it has to do with how you draw the diagram. So there's a pole, all right, easy enough. It's supported by 2 wires on opposite sides. Okay, so there's a wire here, there's a wire here. At the top of the pole, the wires form an angle of 60 degree. So is the entire angle 60? Is the right angle 60 or is the left angle 60?
The entire thing.
On the ground, the ends of the wires are 15 meters apart. So that's pretty easy as well. This is 15. We don't know if this is the center. Keep that in mind. We don't know that.
Mm-hmm.
One wire makes an angle of 45. Question is, how long are the wires? So we need to find this side, AB and BC, and how tall is the pole? And we also need to find BD. So these are our 3 unknowns, AB, BC, and DB. All right, how do we even begin with something like this? How would you attack this? Any ideas? What would you do if you saw this? I'll give you a hint. It's a sine law problem. Probably not a SOHCAHTOA problem. So you have to think of it in terms of sets and whatnot.
So you have to find the side length for A.
AB, you mean? Or AD? Here's what I would do. Find angle C. You can do this in your
Mm-hmm.
head. What's angle C? It's going to be 180, right? We're looking at the bigger triangle, triangle ABC. So if A is 45, B is 60, C is going to be 180 minus those two, no? So it's going to be 75. Cool? Now ask yourself, do we have a set in the bigger triangle? Yes, we do. You see this? B and B.
Mm-hmm.
So we have a set, so it's going to be a sine law problem. Using that set, we can find both AB and BC. Let's do that. So it's going to be sine B. What are we looking for? We're looking for sine length. So it's going to be B over sine B, where this is B, is equals to, this is A. It's going to be A over sine A. And it's going to be the same thing for C as well. But let's just find this. So it's going to be 15 is small b. Sine B is 60, so that's B over sine B equals A. We don't know, we're looking for that. A is BC in this case, one of our unknowns. And sine A is 45, like that. So to find BC, multiply both sides by sine 45. So BC is 12.54. How do we find AB? This side length. I'll give you a hint. We know the opposite angle, and there's a set in this triangle. So this is just another sine law. Here, let me set it up. It's going to be B over sine B, just like it was before. But instead of small a over capital A, it's going to be small c, which is AB. This is small c, because it's opposite to angle C, divided by sine C, like that. So just like before, like here, B over sine B is unchanged. It's going to be 15 over sine 60 equals to C. We don't know. That's what we're looking for. That's AB all over sine 75. To solve for AB, you'll just multiply both sides by sine 75. So that gives me AB is 16.73. So we know this side as well, 16.73. How do we find the height of the pole, which in this case is the vertical line BD? Do we have enough information to find BD? You just use SOHCAHTOA on either triangle. Because on the left triangle, let me show you. So on the left triangle, it'll be sine. So sine 45 is equals to BD over 16.73. Multiply both sides by 16.73, you're done. On the right triangle, it's the same thing. It's going to be a sine problem because we don't know the adjacent. Sine equals BD over 12.54. Multiply both sides by 12.54. And both of these should give you the exact same answer because it's the exact same vertical line that we're looking for. And we are done with this problem. Cool? So that's kind of a difficult one. Here, this is the same question. It says find the depth of this pit. So again, we're looking for the vertical line. So this is A, small a, this is B, small b, this is C, small c. Call this maybe D. So we're looking for the side length CD, the vertical line. It's the exact same question as the one that we did before. Well, the process is the same. The diagram is different, but the process is exactly the same. I'll give you a hint. You either got to find A, side length A, or side length B. You can do either one. You either find A or you find B using the sine law, step 1. Step 2, you're just going to use SOHCAHTOA from there. Let's see if we can find side length A. We need a set. Do we have a set in this diagram?
No.
No. Can we find angle C? We don't have it yet, but can we find angle C?
Yes.
Yes. Here's a lazy way of finding angle C. To get 19, to get 90 from 75, you need to add 15. To get 90 from 60, you need to add 30. This angle is going to be 15 plus 30. Sorry, there we go. That's 45, or you can just do 180 minus as well. So now we have a set. Now from here, it's the exact same thing. We either find A or B. Let's find A. So it's going to be A over sine 60 is equals to what over what? We need a known set on the right side.
(210 over sine 45).
Yes, 210 over sine 45. So now that we know side length A, we can just plug this in. 210 divided by sine 45 times sine 60. That is 257 meters, or whatever this is. It's meters. How do we find CD, the vertical line, if we know this is 257? You want to strictly look at the right triangle. You want to strictly look at this triangle. And maybe this will make it easier. So if you strictly look at the right triangle, it's a right angle triangle. This angle is 75, this angle is 257. We're looking for this.
You use sine?
Yeah, and you're done. It's just gonna be sine 75 is gonna be CD over 257. Multiply both sides by 257, and you are done. So now we have a parallelogram. So let's say this is our parallelogram. Maybe I'll just draw it like this. Doesn't have to be super clean. Let's call this A, B, C, D. It says the short sides are 12 centimeters. So this side and this side are 12. They're going to be equal. The side lengths in a parallelogram are equal. The acute angles are 65. So is angle A 65 or angle B 65? The acute angles, it says.
A.
A is going to be 65. So this is 65. Similarly, up here will be 65, yeah? Parallelogram, rectangle, the opposite sides are equal. Well, in a rectangle, it's 90, but in parallelogram, there are supplementary. They will add up to 180. So that means this one will be what? 125. This one is also going to be 125. And the short diagonal, which one is the short diagonal? BD or AC? They're not equal. BD or AC, which one is shorter?
BD.
BD. So we know that this side length is 15. Now the question is find the long lengths of the parallelogram. Cool. What's our approach here? We already have a set. 65 and 15. Opposite angles and side lengths, that's a set. You want to think about the diagonals. Does diagonal cut the angle in half? Think about it. Does a diagonal cut the angle in half? And the answer is yes, it does. And that's the only way to do this question. Actually, we know this side. We know this side. We know this side. Let's double check, actually. Let's double check. So I'm going to redraw this. Shouldn't take too long. If you're unsure, you can always double check. We know that's 12. We know that's 15. We know this is 65. The question is, what's this? What I'm going to do first is I'm going to find this angle, okay? And then we can do 180 minus. So I guess for this question, you need to use sine law twice. So let's say this is whatever, it doesn't really matter. So sine A over 12 is equals to sine 65 over 15. Sine 65 divided by 15 times 12. Sine inverse, it's actually 46 degrees, 46.47. So it actually doesn't cut it in half, not for a parallelogram. For a rectangle, it does, not for a parallelogram. And to find this, you just do 180 minus both of them. Minus 65, that's like 68.5 degrees. But isn't that exactly half of this? 125 divided by 2? No, it's not. No, it's not. Half of this is 62.5. This is 68.5. So there's a big difference there. And from here, it's easy to find this. It's just going to be question mark over sine of 68.5 is equals to 15 over sine 65. Multiply both sides by sine 68.5 and you are done. Cool? All right, so it does not cut it in half. The diagonal doesn't cut it in half. And again, anytime in doubt, when you're in doubt, you can always double check like we did here. It does not cut it in half. All right, let's call it there for today.
Okay, thank you.
See ya.